Today with us from Greenheck, we have Brian Southworth and Tyson Sargent. They're going to be going over our HVLS. That's our high volume, low speed fans. Also alongside us, we have my fellow sales engineers from Dorsey. We have Blake Bonham from Spokane office. We have Chris Woldridge and then Scott Boucher. We will kind of be in the background. Please hold any questions till the end. If there's anything important that we need to address during the presentation, we'll pause it and one of us will jump in and answer the questions for you. But I think we're going to have Brian kick us off, maybe give us a quick 30-second introduction, and then, yeah, excited to watch this.
Yeah, welcome everyone. So we'll just kick this off. So this is our team. So myself, Brian Southworth. I've been with Greenheck now 6 years as HVLS, and I'm an application engineer specialist. And then with me, I also have Tyson.
Yep. Hello. Thanks for taking a little time to get with us today. Yeah, product manager for HVLS. I've been with Greenheck for about, I think I'm coming up on 4 years. Spent a lot of time in the HVLS industry. I was with a competitor for about 12 years. So done a lot, seen a lot, all with big fans. And then I was also with Johnson Controls, we'll say, in the interim between the two companies. So kind of always been in the HVAC world, but glad to be here. We'll run through all of this. I can talk about Dan Tolles. He's my counterpart. I believe he's been here like 12 or 14 years. So he is a wealth of knowledge. Very good at his job. Can't say enough good things. Duncan, he is came over from what we call our AMAST group, which is kind of like the Advanced Engineering Materials group. So very, very sharp and engineering minded, but he has been a very good addition to the team. And then customer care, can't say enough good things about these guys. They do a lot for us and for the customers. But Nicole, Mitchell, Joe, Jason, if you guys email the AI fans URL, you need questions, selection help, one thing after another, it normally starts with them. So it's a very, very good team. Obviously not, gigantic, but we do a good job. So anything we can ever do, please reach out to any one of us and we'll figure out the right person.
So here's the agenda. So we're going to talk about fans, controls, features, how you can apply our fans to the market and applications, competitive comparison, and if we want to get into ECAPS tools, we can definitely go through that. I have that prepared. And then, of course, at the very end, we're going to talk about our next generation, our Gen 2 fans for the HVLS. Product overview. So here's some of the HVLS fans that we have currently. So our DM fan, that's for smaller spaces. Then we also have our DC5. We have that one going down all the way down to a 4.3 foot diameter fan. So it's more of like your residential models. And then once you get up past 8 foot, so 8 foot to 14 foot, that's where you're going to get into that AMCA certification. We'll talk a little bit more about why that's important, but that's where your AMCA certification is going to apply. And then as you get bigger with your spaces, you're going to move into your Model DS. So we have our 3-bladed and 6-bladed. Main reason why we offered one versus the other is essentially pricing. Less blades is a cost savings for you, but you're sacrificing some of your performances. But the real main differences between the two models here, the DS and the DC, is going to be your voltage. So if you needed a fan that was 115 single phase, that's always going to be a DC fan. It would never be a DS fan. Once you move up past your 208 single phase and then into your 3 phases, that could be your DS fans. So just to kind of put out the main differences between some of these fans here. And here's some of the stuff that I just kind of covered already for the product information. You know, the diameters are there, the performance is there, horsepower. That's one of the questions that I get for horsepower is why do we only offer certain horsepowers and we don't really like deviate from those? It's really based off of your performance. So these fans are so efficient that we don't need anything bigger than what's required. So the 1.5 horsepower motor is going to be the maximum that we offer. You know, we don't need bigger horsepowers. Like we're not going to give you more than what you need. So that's one thing to note there.
Yeah, only point I'll add there is even with other HVLS providers in the market, depending on the model and the manufacturer, about the largest you'll ever see is about 2 horsepower. We normally talk about these motors in torque, which of course is very related to horsepower, but you'll see kind of in some of these coming slides if we don't reference it as horsepower, just because market wide most people talk torque. To Brian's earlier point about the voltage and phase requirements, that DC5, like he said, only comes in single phase. If you need 3-phase, we have the DS3 or 6, but in similar sizes. So while DC5 is only 7 or 8, up to 14 foot in single phase, we have 8 all the way to 24 in the 3 or 6 DS model.
So here's some of the controls that you could utilize with some of our fans. The first one, we're going to start from left to right. That's going to be an IR remote or a TV style remote is what I kind of like look at it. So that's going to be for your DM fan. A lot less wiring. It's essentially meant for residential. So you literally would point to the fan as you would with a TV, and then you can control that fan or multiple fans. Just depends on how you program it. The keypad, standard touchscreen, and the advanced touchscreen, those are going to be for your DC fans or your DS fans, and it really depends on what you're going to do with it. So as you can see, the control options, you can control 1 fan, 3, 5, or 10, up to 10 fans with that control. Once you start getting into some configurable options, like your grouping or your scheduling or backnet integration, that's really when you start getting into that advanced touchscreen control. Otherwise, the keypad and the standard touchscreen, they're pretty much the same control, just a little bit, one's a little more easier to use, and it's like your cell phone, and the other one is a little more robust. So. Some features and benefits that we're going to talk about mainly with the advanced touchscreen control, as you see on the right hand side. So we do offer a surface mounted and a recess mounted, but the design for all of our controls and configuration and fans for that matter, it's essentially a plug and play installation. So we try to make it as easy as possible, and then using the auto detection to connect to the fan. So as soon as you connect to the fans with the controls, it's our intention that you find the fans as fast as possible. So a lot less troubleshooting, a lot less for you to do once you get these fans up and going. The password protection is available with our standard touchscreen control, but we don't see that very commonly used with the standard touchscreen. It's mainly used when you're into the backnet type situations where they want the advanced touchscreen, locked out and configured.
Yeah, the only thing I'll add here is kind of as Brian talked about, this advanced touchscreen essentially, simply put, acts as our gateway, right? So if you're going to tie it into any sort of building automation system, you pretty well have to go with the advanced touchscreen. The fan itself inherently talks Modbus. So if you had some savvy controls guy that could, get the Modbus, objects and points out of the whatever front end, Johnson, Schneider, so on, they could control it that way. But 99.9% of the time, this is used as the gateway, just to translate between the different protocols. And Corey, I think you put in a question about the controls on the time clock. This one would be the one that you would want to use for the fan scheduling there, the last bullet point. The other ones, I'll say current state, do not have a a way to schedule it, whether it's on date or time. So this is the offering that you would be in for that particular requirement.
Before I became an application engineer, I was with the customer care team. So I did a lot of phone calls and emails and all that other stuff with troubleshooting. So that is, I don't want to say it's a very common question, but that is a question that we do get sometimes. So it's an easy one for us to tackle when it comes up. Some other optional fan features. Of course, we have our standard color finishes here shown, and then also our wood grain. The wood grain is actually a very, very beautiful design. With some of these features, just know that it does increase your pricing, of course, and then lead time. It's something that we have to change out in the factory. So that could increase some of those things. So that would be one reason why. But otherwise, we kind of touched already on the voltage and phase, so I'm not going to talk about that too much. We do have a few different optional mounting kits, which would be the wood grain, the I-beam, I'm sorry, wood grain. We do have the steel truss, unistrut, I-beam, Z-purlin, and I think that's everything, right?
Yeah.
I'm missing one more. And then we have our drop lengths up to 10 foot in distance. So I'm not going to read everything off the slide because you guys have that already here, but LED lights, UL certifications for dry or damp is part of our current design. Just to touch on our next generation, we are going to be UL wet, which is going to be amazing. So we'll talk on that in a little bit here. Marketing and applications. You want to take this one?
Oh, sure. Yeah. So with big fans, I mean, there's, kind of a few different reasons why you would use them. Typically, of course, they're going to be in very, wide open spaces. It started in agriculture. It's kind of a funny story, but, happy cows make more milk. And if you can increase the airflow around them, that makes them more comfortable. And obviously, they don't have a lot of, electrical air drops, so on, in a lot of these, dairy barns and other type of, we'll say livestock holding areas. So that's where it started. And then slowly but surely it moved into warehousing. Warehousing takes the lion's share of, the HVLS market. I mean, just year over year, that's just where they're used the most. People expect to see them in there. They do a fantastic job. But as time goes, which we'll talk about in a minute, there's, loads more applications. So kind of takes care of the first bullet point, just being high volume of air movement. In the very, very beginning, there were a lot of the, Envirotech or, the smaller ceiling fans that were being put into these same type of applications to try to either get some airflow in there or, de-strat any of the hot air that had, risen to the ceiling. And it just makes a whole lot more sense to have one fan in there that can move, 200 plus thousand CFM versus 20 or 30 of these small guys, for a number of reasons, which I won't necessarily get into all of them, but just suffice it to say the small guys don't push air more than about, 7 to 10 feet, depending on how fast they're running. And it is a, maintenance and install nightmare to put in 30 of these small fans just versus, one large fan. So some benefit there. Low operational speeds. Again, it kind of goes back to the application it's going into. The whole idea is to create for occupant cooling, a sort of an outdoor breeze feeling. It's not going to be, you're not going to walk out of a facility and feel wind blown like you've been staring at a circulator fan or a barrel fan or something like that. Pretty low feet per minute as far as the airflow in the space. And then since there's a massive amount of air and it's moving pretty slow, it doesn't act the same way as far as obstructions go. So while obstructions will knock down the coverage area, a little bit depending on how big they are and so on, is again very different than like a circulator fan that's pointed at, a toolbox or a rack, and that air essentially doesn't go anywhere else. Along with the slower, movement of the fan, you get these lower sound levels. So everyone's experienced those, giant air fans or pedestal fans or whatever that they have in like gymnasiums, for example, where, you're in there for graduation, you can barely hear anything because it sounds like a helicopter's taking off. not a problem here. And then since they're turning lower RPM, they're again consuming a lot less power to do so. So all in all, it's going to affect a very large area. Just for like rule of thumb, 24-foot fan should cover, if it's mounted about 25 to 30 foot above the floor, it should cover a 110 by 110 foot square, right? So multiply that out. I mean, you can get a bunch of different dock doors in that area or whatever is in the actual application. You're going to cover a lot of space with a lot of smooth airflow, and you're not going to consume a ton of energy doing it.
Yeah, just to add on that a little bit here, typically we have a little more interaction because you guys are in person, but that's not a big deal here. So the low operation speeds, our DS 6-bladed fan at 24-foot diameter, the maximum speed for that is only 60 RPM. So very, very slow. And we don't see those fans operating that fast either. They're typically about 50. My sweet spot is about 50 to 75% of the maximum fan speed. And essentially the rule of thumb there that I apply is you want to feel the fan, you don't want to hear the fan. So you want to enjoy it.
So kind of a little bit of I'll call it derivative of the last slide. The two main applications are winter destrat and summer cooling. So there is, within the market, there's maybe some disagreement. It is a requirement by AMCA that all of the fans, HVLS fans, which is defined as 7 foot in diameter or larger, have to be reversible. So all fans that you buy that are AMCA UL certified are going to be reversible. That said, the airfoils on our fans and the other, I'll say, major competitors are all designed like an airfoil, an airplane wing. So you can reverse it, and it will pull the colder air up in the winter and circulate the hot air back down. Obviously reducing your costs, utilities, gas, electric, whatever it is you're using to heat the space. We have a calculator built into CAPS to help you, calculate a return on investment of what that might look like based on the size, what they're paying, all of the different variables that go into it. There are even utilities out there. Not sure well, I guess you guys are kind of spread out, but I know there's some in Rhode Island, there's some in Minnesota, one of the Carolinas. These utility companies, mostly gas utilities, will actually incentivize customers to put these fans in. The number is anywhere from about $1,000. I've seen it as high as $2,500. So a customer puts a fan in that's using that utilities, we'll say gas heat, that utility cuts them a check for $1,000 to $2,500, and it's all based on destratting in the winter. On the other hand, summer, this is, since we're putting these fans a lot of times in spaces that don't have air conditioning, whether that's manufacturing, warehousing, whatever, again, you're just going to get that comfort cooling. It's all based on ASHRAE Standard 55. We have a calculator for that as well. There's some environmental and also personal factors that you can put in there. I think we'll talk about that on another slide. But point is, you can essentially get this cooling effect where the ambient air temperature is what it is. But you can get up to about 15 degrees of perceived cooling in the summer months by moving these fans in the forward direction and blowing that air across the skin. So if you can take a facility where workers are working out, or if they're even a restaurant sitting in the heat out on a patio, whatever, if you can get that airflow up about above 35 feet per minute, all the way to 200 feet per minute, you're going to get some amount of perceived cooling, which is going to keep them more comfortable and keep them more productive, at least in work environments. So as far as I'll say typical applications, now I don't know if it's coming through with me on the screen here, but I love big fans, so I think they go everywhere personally. But the big hitters, of course, are going to be the industrial, which would be the warehousing, manufacturing. Aviation is it's aviation and automotive are very similar. It's kind of a front of the house versus back of the house. You'll see them, in the gates and terminals, depending on, how high the ceilings are, even above or below the Mason-Dixon, so they can either recover the heat that's trapped in the ceiling, or just increase the perceived cooling so they don't have to put as much load on the HVAC system. Same with automotive. For whatever reason, these things have been growing over time, and not necessarily just from its footprint, but all of the glass that's on the front of these buildings just increases the heat load into, the sales lobby area. And increasing airflow in there does a lot as far as not having to provide as much conditioned air to the space. Back of the house, automotive would be more like the shop environment. I think that's pretty straightforward. Some are air conditioned, but same thing. People are working on, hot engines, exhaust, so on. It's just very, very nice to get a lot of air movement in there. And then aviation, hangars are like the perfect application because they're big, they're tall, wide open, and the air flows forever. So you can, really get away with fewer fans or not as large of fans in an application like that, and get a lot of results. I'll say the secondary or maybe even tertiary applications would be more like your stadiums and arenas. We see an uptick in this, year over year for about the same reasons. It's just uncomfortable in some of these areas. I've been to a number of minor league baseball stadiums that have them. Cardinals, Busch Stadium, we see plans coming through, for a number of different football fields, arenas, like pretty much all college football stadiums at this point have big fans to some extent. The new soccer stadium down in Nashville that was just built, they have HVLS fans all over the place. Agriculture, I'll kind of group that with even like a Sam's Club, a Costco, these big box grocery stores. It's actually kind of two-tier there. Again, cooling, air movement, just to relieve some of the HVAC equipment providing the air. But number two, it actually sweeps some of the what the plants or produce actually creates, which I'm no chemist, but understand it is it gives off a little bit of like ethanol, and the quicker that you can get that away from it, those plants or produce will keep longer. So there's been a few studies done out there, and you'll see them in those applications either for one of the two or a combination of. Fitness goes without saying. I don't know the last time I was in a fitness facility that didn't have big fans. So it's a very, I'll say, saturated market as far as HVLS goes, but it just makes a ton of sense. So those are the main ones. People put them in their homes. People put them in education, the gymnasiums. That's a big draw. Any of the schools, especially newer ones, the vestibules, when you first walk in, they have very high ceilings. We see a lot of big fans going in those applications as well. So it's kind of across, the breadth of all these different places that big fans can be put. It really just comes down to, is the ceiling tall enough to fit a big fan, and does it make sense to either recover heat or add a little additional cooling? Some architects, owners, honestly just like them for a wow effect, or make it like a centerpiece of the space, which I'm all for as well. But as far as bang for your buck and actually putting it in for getting the cooling and recovering the heat, these are going to be your main markets.
Yeah, no, that's all good information. So anytime you get into some of these applications and you're like, I don't know how to lay this out, or I don't know if this is the right application, because like the automotive, they got a lot of stuff hanging from the ceiling. Fire departments, they got a lot of stuff all over the place, and technology all over the place. Like, just reach out to us. I'll share that phone number and that email that you should reach out to. But just reach out to us with some plans. It doesn't have to be something that's finished. A draft is fine, and then I can help you with the layout. So that's one thing that I also do for Greenheck, is layouts with fans, and give you all of the understanding that you really need to understand why our fans are beneficial, where they could be placed, and then how fast they should be in rotation. You know, in the industrial, one thing that people don't really think about is, and it's kind of like back there, is in yellow, is the overhead cranes. I mean, those overhead cranes, they don't move, and you know, our fans, the blades, they do move, just like every HVLS fan manufacturer. So we got to make sure that we have proper clearance and proper safety is in place. So I'm not just thinking like let's get a fan in this place and then let's get it sold. I'm thinking safety. So that's one thing that Greenheck definitely pushes. Some other safety concerns is going to be on the left-hand screen would be the sweating slab syndrome. For those of you that aren't familiar with that, that's when there isn't a fan in this area, and the air temperature inside the space versus what the temperature of the slab is are two different temperatures. And then therefore, when the concrete is heating up, it actually sweats the slab. So that's where the sweating slab syndrome comes from. So by putting an HVLS fan in there, it actually creates more air movement for that, so therefore you're not getting that unsafe condition with the sweating slab, and then it helps regulate the temperature from floor to ceiling, especially with that concrete. So it reduces a lot of those safety concerns.
Yeah, the only thing I'll add is sweaty slab syndrome. We see it a lot. Air movement, of course, you know, helps that, whether it's just keeping the concrete and the ambient air temperature, I'll say further apart from dew point, which is what causes the condensation. The other hand, obviously air movement is going to help evaporate any sort of, you know, whether it's just plain old water, or it's condensing. Both of those have been applications over the years. Another one, you know, just from experience, anytime you have like, you know, the steel industry, these big rolls of metal steel, increasing the airflow in there actually saves them product. And though to scrap a big, you know, roll of steel is very expensive. So it's another, like I said earlier, call it a tertiary application. You don't see it a ton, but anything you can do to increase the airflow to save product, whether it's getting damaged from condensation or it's just generally keeping them dry. The big fans do a very good job of that. The only other application I'll even mention is like pallets. There's a lot of, you know, there's certain applications where they'll have essentially an entire warehouse filled with pallets that they're using in their distribution center or whatever. While those pallets aren't exactly high priced, you know, keeping them solid, not wet, it does save them money. So I've seen that from time to time as well, or just increasing the cool down time whenever, you know, like a foundry or products are coming out of an oven or something, just increasing the, call it the dwell time or I say decreasing the dwell time that it takes to get them back down to temperature, just speeds up the process. All of those things have dollars attached to them.
Then, of course, you got your other applications for architectural design. You know, oddly enough, we actually had a request early on in the HVLS timeframe where the architect just wanted a fan and they didn't want it to move or rotate or do anything. They just wanted it to be a big fan inside the space. So we get some odd requests, but I mean, as you can see here, we do have a lot of different color variations, which, I mean, the color of the spectrum is there. We also do match color chip too. There was a job that I helped out with at LSU for their weight room where they had their special purple that we utilized for them, and then we used our safety yellow. So we do get to do some kind of interesting type of designs. So another safety thing would be pest deterrence. On the right-hand side, that's all of these photos that we're sharing here. These are not AI generated at all. These are live photos. So the one on the right-hand side is actually local here. It's one of the baseball stadiums, as you can probably gather. But keeping those pests out of those areas. I mean, nobody is a fan of getting some droppings on their head, you know, while they're at the seat enjoying the game, or at least trying to enjoy the game. So having that fan there in rotation, besides it being, you know, a positive experience for them to feel the fan and the effects of the fan, that's one other reason. So. And the same would be applicable for the other side. Competitive comparison. So one thing that I want you guys to think about when you're talking, or when we're talking about the competitive advantages here is, why is our product better? What did we do to make our product better? One thing that I really like to pick on for our design versus others is going to be the impact detection. For those of you that aren't familiar with that information, so impact detection is we did a test. Our engineers had a nice little field day where our fans were in operation in a gymnasium, and they threw basketballs, baseballs, footballs, volleyballs at our fans. And one question that we get is, why don't you guys offer your fans with guards? And that's essentially because we have this impact detection. So the soft impact that occurs when you're getting these balls thrown at our fans, it allows the fan to just continuously rotate because it's a soft impact. It's not a hard impact. Now, a hard impact would be defined as running into one of the blades while it's in rotation with a pipe or a chunk of wood or even a forklift. Believe it or not, we have had situations where that's a phone call that I unfortunately get where, hey, I ran into one of our fans with a forklift. What do I do next? Well, we can talk about that later. But so the impact detection with the hard impact, we ran a pipe into our fan blade to make sure that it was working. And so what that does is it immediately stops the fan. The fan does not continuously try to rotate. Versus other manufacturers out there, that's something that they do not have. So the impact that they receive is they'll get a hard impact. The blades are all bent up or whatever shape they come in after that happens, and then they try to continuously rotate. So that's a very unsafe condition. You got to run over by the control and turn that thing off, or by the safety disconnect, versus having that impact detection. That's probably one of the number one things that I really do enjoy about Greenheck, because we really pride ourselves on all of the safety that we put into this thing. So a lot of these are very redundant, but they are very important to us. So another thing that I like to talk about is the easiest to install. So we're 35% lighter for fans. So essentially putting up this fan is a lot easier to do with a lot less people. Some of these fan manufacturers out there, they're 300 plus pounds just for the fan itself, and that's not even including any of the accessories. That's a lot of weight. I mean, once you start getting out to the 24-foot diameter fans, yeah, you're going to need to have two people on these blades. But essentially, that was one of the reasons why we looked at this. Another thing that probably gets missed on some of the safety side is going to be that sheriff's badge. So when you're looking at the fan picture here, you have the Greenheck logo, which is our drive, the backside of the drive, and then below that is our motor. And then what we're calling the sheriff's badge is actually the connection plate that goes between all of the blades on the fans. Now, there are other manufacturers that do have something similar to this, but that would be 6 or however many blades they have. So we'll just say 6. So 6 different plates that are attached from the motor to the blade, versus ours is one complete package. That's one complete plate that's attached to our 6-bladed fan that we're showing here. We have that for all of our HVLS fans, so not just the one that we're showing here. Again, I talked about the plug-and-play design, so that's all factory installed for you. Essentially, it's a male to female connection. Once the fan's installed, you apply your electrical to the fan, and you're connected with your networking, depending on how that actually is. Then it's a plug-and-play design. So that's what we're showing on the right-hand side of the screen. And of course, we're a manufacturer of over 75 years of experience. So, anything to add?
No, I mean, I will point out the 50% lower clearance. Brian talked about this a little while ago in the application. I believe it was labeled industrial. This is, a pretty big deal because those industrial spaces, they do get hot or you want to get the heat out of the ceiling. So with ours, and since we are AMCA certified, which, it's per standard 230-15, if you guys want to look it up, point is that's where all of our performance data comes from. So we know that our fans move the same amount of air that is reflected in our caps or e-caps, or even if you get in like the CCMS database online, all of our performance is out there as well. It's all based on AMCA, and we know that we can get to that performance with only a 3.5-foot drop. Where other manufacturers require 7, sometimes even up to 9 feet of drop. So while that goes a long way in a lot of different applications, because, you know, architects, owners, so on, you know, they don't always want the fans very far out of the ceiling. They want to keep them tucked up just from a aesthetic standpoint. Specifically within those industrial settings where you can keep the fans up, whether it's away from equipment or above the overhead cranes. It's, again, the perfect spot for it, that we kind of have a nice little niche in, because we can prove that we get as much performance as we claim we do based on AMCA. So only main takeaway, only 3.5 foot drop, where others are going to get 7 or 9. Obviously, you can't put those in if you have overhead cranes. Overhead cranes are in applications where occupant cooling would be of the utmost concern. It's almost always why you go into facilities like that and they have, you know, dozens, if not hundreds, of circular fans that are mounted to columns or whatnot. So good application, but so far we're the only guys that can prove the performance in those tighter spaces.
Yeah, and just to double tap on that, we are the only manufacturer that has every single one of our HVLS fans AMCA certified. There are roughly 5 different manufacturers out there, but they have 1 or 2 of their fans AMCA certified. So, and as Tyson already mentioned, you know, look at the distances, that the clearances, because even though that model may be AMCA certified by those other manufacturers, look at the drop length, because sometimes that really actually pushes them out of that AMCA certification. So that's one leg that we like to step on. So competitive advantage is continued. You know, we're in industrial leading performance, 15 to 30% more airflow, cooling effects up to 15%. And that the cooling effect really depends on, you know, what's within the space, what type of atmospheres in that area. So it depends on if you're in Arizona or if you're in Florida or if you're in a winter of Wisconsin. So that metabolic rate is where that actually comes from. And Tyson already mentioned the ASHRAE 55. So how that's calculated is essentially, let's say that it's a fitness area and everybody's in shorts and a t-shirt and they're sweating. Well, that metabolic rate cooling effect is actually a lot higher, just because that's the type of environment it is. So the effects of what is being done within the space actually increases or decreases. And same thing with the airflow of the fan. The higher the cooling effect, the faster that fan is more than likely actually rotating, depending on what the site is. So a lot of it is site dictation and how you intend to utilize the fan.
Yeah, I'll say the last 2 bullet points there: industry leading performance, the 20% more efficient, 510 dBA quieter. That really speaks to, I'll say, just the powertrain of our fans. They're all direct drive, so there is no gearbox. Obviously, that increases efficiency because there's no gearbox losses, as well as, you know, the motor itself doesn't have to run at a higher RPM and then be reduced down through the gears to get the RPM of the airfoils themselves. So you're going to increase the amount of efficiency purely just by that. And then secondary, the 5 to 10 dBA quieter. Again, gearboxes, I mean, there are, you know, nice ones out there, but it's a gearbox at the end of the day. It's going to degrade over time. It may be very quiet, you know, out of the box, you know, first year of install, but over time, you'll get some, you know, grinding, contaminants, so on, will get into the gearbox because, you know, that cavity needs a vent on them, and it'll pull in any sort of debris and so on that gets in the gears. You'll decrease the efficiency, you know, not necessarily by a ton. More importantly, it could make the gearbox fail, certainly could make it more noisy. And then there's always the chance of, you know, gearboxes leaking the oil onto product, people, gym floors, so on. So direct drive, it's the newer technology within the HVLS world, but, you know, Greenheck is well ahead there. So nothing against the gearbox driven fans necessarily. I'm sure they have a you know, a application for them, but based on pricing, availability, and so on, it really doesn't make any sense to go with the gearbox driven fan when you kind of get everything you want in a direct drive model.
That's a great point on the gearbox. I wanted to also mention that, one question that we do get is what type of maintenance do you need on these fans that you're supplying? And essentially that's nothing. Like if you want to go up there and dust off the blades, like that's literally it. There isn't any reason to go up there unless you want to move the fan for whatever reason. But really, I mean, that's it. So, I mean, that's a really big advantage. You don't have to do any real maintenance with these fans versus like your gearbox driven fans. So now we're going to get into a little bit of a comparison for you. So aren't all HVLS fans the same? And that is no. So again, with AMCA certification, that essentially levels the playing field. That everybody that's AMCA certified, they all abide by the same rules and have to test the same way. If you're not AMCA certified, essentially what that allows them to do is to say whatever they want about their fans. They can talk about performances and clearances and all kinds of different stuff. But really, the clearances and performances that we're providing are for a reason. So the clearance would be for some of the standards that are out there, like the NFPA. That's not something that's provided just by Greenheck because we want to. That's for safety, so that's NFPA. The floor to ceiling, the minimum that we would ever allow is 10 feet. That's provided by OSHA. And then AMCA certification for your performance. Those are all rules that we all abide by. So if they're not AMCA certified, they don't have to meet any of those certain situations. So getting into some of the fans that other manufacturers allow, we do know that there is a 30-foot diameter fan. That one cannot be NFPA certified. They can't put that in a sprinkler system area unless the site allows it. I mean, that's the only caveat there. So that's why we only offer up to a 24-foot diameter fan. But with that 24-foot diameter fan at 6 blades, we can offer up to 243,000 CFM. I mean, that's quite a bit of air movement for one fan. With some really good efficiencies. HVLS fans out there in the market, in general, they're very high efficient fans, but AMCA certification is where you're essentially going to get that proof. So some differences that we're showing here between our fan and the Big Ass Fan Basic 624. You're going to see some comparable differences, and this is testing data that we have determined and did on our own. So this isn't through AMCA or anything like that, but the difference is definitely clear in the red.
Yeah, so Brian talked about AMCA certification. I think the only thing I'll really add there, just to kind of, drive it home, is that if it's not AMCA certified, you really don't know what the performance of the fan is because they're able to claim whatever they want. Before AMCA had a standard, I mean, it was all over the map. I mean, people were making some very, very crazy claims. So AMCA certification is extremely important. It's gone through some changes. CFM per watt was kind of where it started. That actually allowed for fans that were very efficient as far as not consuming electrical power, but didn't move that much air. That actually gave that the way that they calculated that gave the advantage to those fans, which I'll say defeats the utility or the purpose of the fan. So in 23015, they revamped it, and now it's a CFEI, which, ceiling fan energy index. So if you're interested, we have a whole presentation just about where all that comes from. It's good to understand, that way you guys can have the appropriate data and, make your selections of number of fans or size of fans, and then, actually have third-party certified performance data to rely on, instead of just using rule of thumb or, some other kind of magic number that's out there. Direct drive fans we talked about, and the performance data. We talked about kind of the bad actors that are out there. We still outperform almost, I'll say, I haven't seen one that we don't outperform, unless they are essentially lying about it. And then just from a standpoint of trying to, provide as much service to the market, whether it's the owners, the engineers, contractors, our reps as well. We certainly rely heavily on our partnership with the reps, but we can do any of these performance-based selections with you. So it's not, even if you don't know AMCA, you're not really understanding what it is, you can rely on us to tell you exactly size, model, and placement, quantity, so on for any given application. We can do the return on investments. We could even do, some of the ASHRAE standard 55 to explain, all the different variables there. So kind of goes back to what I said before, as far as just let us know how we can help and we'll do what we can.
All right, so just looking at a typical HVLS project, so some common notes that we would really like to see as soon as we get some of this type of information. What is the provided manufacturer mounting kit? That might steer you in the direction of a fan. So all of this is really to kind of like drum down to a certain fan. What type of controller is it? Do they need a control that's going to communicate to building automation system, or do they need a simplified controller like our standard touchscreen control? Provided factory supplied extension tube. What is the height that they are recommending? Sometimes that isn't even a thing that's on there. They just say that it's going to be hung at this height, but they don't really give all of the information that is truly needed. So some of that information is really what we need, because those down tubes with our current design, those have to be ordered pretty much exact. And we can offer different lengths of down tubes all the way up to a 10-foot down tube. But some of those that are, to the inch, that would be something that we would have to kind of configure. Another thing that we see is architect to select the final color. I can't say this enough. If we can get the color, then that changes the pricing, obviously, which is something I mentioned in the beginning. But if this is an industrial look, where they don't mind if it's blue or black or something a little more standard, then that's typically what we would recommend going with. And then install per manufacturer's recommendation. How do they recommend, us being the manufacturer, how do we recommend installing a fan? Is it truly a Z-purlin that needs to be mounted to versus an I-beam? Some of those situations that I've been in the past, they do matter, because how this is hung could affect the fan, could affect the performance, could affect the sight, and then the hanging distance. So there's a lot of different things that are in play. And I spoke on the fire alarm. So that's the NFPA 13. So that's the fire alarm situations that we do get into with our HVLS fans. And that's every manufacturer out there. We're not that special that we're the only ones, right? But we do provide a fire alarm with our fan. Or a relay, I'm sorry, a fire relay with our fan. But yeah, these are some of the questions that I would recommend, or that we would recommend that you ask when you're looking at a typical HVLS project. So before we moved on, I wanted to just share, this is the customer contact, point of contact, the AI fans at greenheck.com. You'll see this again, so don't think this is the only one. And then, of course, if you wanted to call us because there's someone on site, they need help right away, we have that 1-800 number here, and then the option 2 is going to be for HVLS support. Either one of these are going to offer you competitive cross-references, applications, layouts, pricing, troubleshooting, and technical support for whatever you need. So we're here to help. That's essentially what we're here for. We're here for you. So feel free. Like, I've been in calls or emails where they're like, hey, I've been working on this thing for like 2, 3, 5 hours at sometimes. Seems ridiculous, right? But there's been times where I fixed their fan in 10 minutes. So when in doubt, just give us a call. All right, so caps and E-caps.
Well, tell me, maybe in the chat, if you guys, I know Dorsey is a big user of caps and E-caps, but as far as everyone else is out there, are you familiar? We can skip over the demo if need be. We're just kind of running a little short on time.
Yeah, we want to make sure we get through the Gen 2, so maybe we should skip over this, and then if we have time at the end.
We did do a separate kind of E-caps tutorial power hour, which is on YouTube. But if anybody needs assistance with how to use the E-cap selection kind of wizard, you can always reach out to your Dorsey team and we can get that done for you. But it's pretty easy. Go to E-caps, click on fans, you can click right on HVLS, and it will just lead you straight through it.
Excellent. Thank you. All right. Driving on. So this, we're going to start getting into the next generation fan. So this is our new HVLS fan that we're showing here. for our DS, Model DS.
Yep. So with the next generation fan, essentially what we've done, like I said, I spent 12 years with big ass fans. Started there when it was very, very small. And then, was there over the years and did a lot for them. Started in engineering, got into sales, business development, back into product management, and so on. Point is that I've been in 1,000 of these facilities, in front of any engineer that would give me time, as well as contractors trying to understand, exactly what it is that they want with these big fans. So I've taken those 12 years along with all of the customer service stuff that Brian's dealt with over the last few years. And then, like I said, Dan Tolles has kind of been here with Greenheck since the genesis of HVLS, Greenheck HVLS. So we have a good team that has been in front of, talked to from the beginning to the end of why people want these fans. And we truly believe that this Gen 2 does a very good job of taking all the different issues, problems that might arise, whether that's pre-sell, post-install, and wrapping it all into this Generation 2 DS fan. So I'm extremely excited about it because I don't know of any questions or applications or issues I've run into over all the years that this fan doesn't have a solution for. That said, it's a little bit of everything, whether that's for the owners and architects. Generally speaking, they're just looking for, comfortable indoor environments. We're increasing our airflow on the fans and actually decreasing the amount of power that it consumes. So we're kind of getting the best of both worlds there. Any sort of aesthetics, that's something that, we can do different colors and so on, but people, when they see big fans, I'll say 90% of the time, they want it to look appropriate for the space. I don't think our current versions necessarily look bad, but it is a motor attached to a down tube and the drive is kind of stuck on the side. People want these things to look a little bit, more meaty, bulkier, while not giving up, I'll say weight or performance, so which we think we've done with this Gen 2 fan. High quality products. We've done so much testing on this Gen 2 fan that, I would love to roll out essentially the industry's longest warranty. And I think we might be able to get there. Biggest hangup is another difference between Gen 2 and Gen 1 is we're actually manufacturing these ourselves, the motor and the drive, where we were kind of taking not an off the shelf, it was licensed to us. So we're the only guys that had the Gen 1 motor and drive, but it was coming from a different manufacturer. So since we're going to handle the whole supply chain and the manufacturing, we're able to get a much better fan, a much better drive, and then, cut out the middleman. Probably said a better way, but we can pass on that savings to the market. So we're getting much better product at a lower price. Obviously, that drives lower or faster return on investment. And in a couple of these other bullet points where we talk about short and consistent lead times, which would be, more important to the reps and the contractors, occasionally the owners or engineers. Lead time is important. But since we are controlling that whole, chain of everything that goes into these fans, we can pretty well guarantee that we will be able to drive our lead times down substantially, which has kind of been a thorn in our side, at least since I've been here. Mechanical engineers, we talked about all the different tools that we have, to provide you performance data that is certified, and then the calculators to, help you with ROI or understand how many fans it's going to take. Since this fan is moving more air, you should need less or smaller diameter. And then the control options, like right now, like I said, it's inherently a Modbus controlled fan. Although the advanced touchscreen acts as that BATnet gateway, that's pretty much the only control option that we have. With this new one, not only are we doing the standard Modbus, We will have backnet inherently. We will have a couple different analogs, whether that's 0 to 10 or 4 to 20. And we even have a daughter board built in, which we will have. It won't be on initial rollout, but we can essentially use this daughter board connection point to do wireless control if we wanted it. It's kind of boundless as far as what we can do with the connection point from a control or update standpoint. So it's just kind of like think of it as a flexible and expandable option for the future. Competitive pricing, I talked about the whole supply chain and handling it all ourselves. That's kind of where that comes from. The easy installation. So this is pretty important. So with fans now, essentially what you get is a fan that is in a lot of different parts and pieces. There's a bunch of manufacturers. They all do it different. Some assemble a lot of it. Some try to keep it very simple, and it's more of like your IKEA situation. So with us, we understand that in the market, the less they have to put together, the better. Not from a competency standpoint, but just from a speed. So right now, our if you just list out the number of steps we have with our current fan, which based on tests with other installing other manufacturers' fans, it can be anywhere from 25 to 40 different steps. Big ass fans, just because I know that product. It's 42 to 46 different fasteners that you have to put together. Both of those with our new model fan is cut down by half or more. So we're talking about 12 steps, maybe. And that really depends on what kind of down tube and how far you're trying to drop it. Main takeaway is the fans coming out of the factory, tested, fully assembled. So we have what we call a backbone that's connected to the axle or the stator of the motor, and then the drive is mounted onto that, very similar to today. But there is a communications port in that drive that is just a 4-screw connector. So if you wanted to get in there and mess with the rotary dials and so on, whether you're trying to address or so on, it's all right there. Your high power and your low voltage stuff is completely separate, which is not that common in the industry. So a little bit of a safety thing there. And then as far as the aesthetic cover, it goes over the top of it. Brian mentioned earlier, all of this, that the motor package and the drive package is all IP66, which is not necessarily the same as your NEMA 4X, right? NEMA 4X is actually third-party certified by UL. IP66 is a self-governing test, so people can claim to be IP66 and not really accomplish anything. So the 4X is important there, but for argument's sake, is IP66 rated equals 4X for us with the UL certification.
Tyson, can I just hop in real quick? We're right at 1, so if anybody needs to jump off right now, thank you for joining, and thank you again, Tyson and Brian. If you have a couple extra minutes, Tyson, feel free to keep going, and we'll answer any questions in the chat. But thanks again, fellas.
Yeah, no problem. I'll talk about this stuff all day, so you probably have to shut me down here soon. So yeah, we talked about what we're getting in the higher torque motor. Is going to be more efficient than even our lower torque is today. IP66 4X. We're increasing the operative temperature just because you get down into the deep south. It can be extremely hot, especially in the ceiling. Some of these fans derate in those environments, which again kind of ruins the utility. The control options 0 to 10, 4 to 20. When we're talking about getting off of a job site for a mechanical contractor, this is kind of a big deal. It doesn't matter if it's Big Ass Fans or Greenheck or any of the other guys out there. Whenever you're integrating these fans into building automation, it almost always causes an issue, and then it becomes everyone's favorite fight. The equipment guys are pointing at the controls guys. The control guys are pointing at the equipment guys. So with this 0 to 10, 4 to 20 analog control, or the next bullet point, the headless control mode, What that allows the contractor to do is go in, install the fan, get power to it, and they can prove the functionality of the fan before it's ever tied into the the head end or whatever overall automation system is in this space. Daughter board IO, we talked about commissioning and diagnostic modes is brand new to the market. No one else offers this. Commissioning goes back to what I was talking about as far as getting the contractor off of the site after installing. They can run the fan, run the commissioning mode. It will run it through, forward, backward. Look at all the amp draw, all the different points that you're going to get within the Modbus object list. It can spit that out if it's tied into BMS, but you essentially are going to have a report of sorts that says everything checks out. The fan was tested at the factory. It's installed. Everything checks out after install. It's ready to go. So big deal there. Diagnostic mode. I mean, depending on how you install it, a lot of different hands or trades touch these fans. It's not always the mechanical contractors that install them. Sometimes it falls to the electrical side of the spec. Then you have electricians installing them. Not everybody, is created equal as far as installers, or at least their understanding of doing that. So having this fan where it comes out completely assembled and ready to go goes a long way, whether they're not that experienced or very experienced. It's essentially ready to go out of the box. And then we have increased cooling effect. Again, kind of just speaks to the bump in CFM that we're getting, which is substantial. We're going through the AMCA testing right now, so we didn't want to put a specific number out there, but just suffice it to say, we were already top of the mountain. We're going to be even higher, along with increasing the efficiency, which I understand is kind of hard to believe. It has to do with the technology of the motor, which I'll leave out for now, because I don't want to put anybody to sleep as far as how windings work and transverse flux. So hit the next one. Only thing I'll point out about this is that efficiency. So while AMCA has the requirements on the standards of how the tests are run, obviously DO governs those. So the CFEI currently is at 1.0. They have a schedule. By 2027, it's supposed to be bumped up to 1.25, which Gen 1 would have been okay with. But since we have the new technology with the new motor and we're introducing the Gen 2, what this does is it's actually going to put us more than 10 years ahead of the DOE schedule as far as them increasing what the efficiency is of these fans, and by law should meet to be able to sell at least into the US. So that is it as far as the major points, but questions, concerns. We have a few other products on here that we didn't really talk about. DDF fans in the upper right hand corner is our Arius Zoo fan equivalent, so a few different sizes in that. And then of course we have the whole circulator line. It's kind of goes back to Greenheck being in the air movement business for 75 years. Even if, I'm very biased, I want a big fan everywhere we can get it because I think they do such a good job. But if it does not fit, doesn't make sense, we have a breadth of offering, that Dorse can help you guys with, whether it's, any sort of exhaust, sidewall, panel fans, so on. That's really the advantage of going with Greenheck. It's the old, one hand to shake, one throat to choke sort of deal.
All right. Well, awesome. Thank you, Tyson. Looks like we've pretty much answered all the questions in the chat. If there is anything else, please feel free to reach out to your Dorsey rep. And yeah, awesome presentation. Thank you guys.